So first question here, we have u is 3 minus 6i and v is 1 plus I. So we want to do u plus v. First one. Same as algebra, we're just going to add the real components, you could call them, and then we're going to add the imaginary components. Imaginary components just means the guys with an I in them, and the real components are just the guys without an I in them. So then 3 plus 1 is going to give us 4, and a minus 6i plus 1i is going to be minus 5i. So that's u plus v. Then u minus v is just going to be 3 minus 6i minus 1 plus I. So that's going to be 3 minus 6i minus 1 minus I. And then same again, 3 minus 1 is 2, and then minus 6i minus I is minus 7i, like that. Then u times v, that's going to be 3 minus 6i times 1 plus I. And the same as algebra, just multiply out the brackets how you usually would, split and repeat. So you're going to get 3 plus 3i minus 6 minus 6i squared. Remember, I squared is equal to minus 1. So we're going to have 3 plus 3i. Oh, sorry, that should be actually minus 6i there. Yeah, because you're going to multiply them too. So that's minus 6i plus 6, because I times I is negative 1, and we have a minus here, so it'll become a plus. So that's going to be 9 minus 3i, because we have the plus 3i there and the minus 6i. Then the hardest one, u divided by v, I think. Yeah, u divided by v. So that's going to be 3 minus 6i divided by 1 plus I, like that. Yeah. Now, remember, we can't just do that. We have to multiply by the conjugate of the bottom number. And the conjugate just means you flip the sign of the complex part. So whatever is in front of the I. So here we have 1 plus I. The conjugate is 1 minus I. So then we're going to have 3 minus 6i times 1 minus I, all divided by 1 plus I times 1 minus I. Multiply that out, you're going to get 3 minus 3i minus 6i plus 6i squared, all divided by 1 minus I plus I minus I squared. Simplify that, you're going to have 3 minus 9i minus 6, because I times I is negative 1, so I'll become minus 6. Then on the bottom, those i's are going to cancel, and then the I squared is going to be minus 1, and since it's a minus there, we're going to have 1 plus 1 on the bottom. So that's going to be minus 3 minus 9i divided by 2. So that's the final answer. Now, find the complex roots of the quadratic. F of z is z squared plus 3z plus 5. Now, remember, normally for a quadratic, if it's a positive in front of the x squared or the z squared, it's going to look something like this. For a complex quadratic, the graph looks actually something like this. It doesn't actually intersect with the x-axis down here. So we're going to have complex roots. So, same as usual. Just a is equal to 1, b is equal to 3, and c is equal to 5. So, remember, we have like ax squared plus bx plus c. But the x's are just z's here. So, minus b formula, x is equal to minus 3 plus or minus the square root of 3 squared minus 4 times 5 times 1, all divided by 2 times 1. So that's going to be minus 3 plus or minus the square root of 9 minus 20. That's going to be minus 11, all divided by 2. So that's right, isn't it? 3 squared minus 4 times 5. Yeah, minus 11. So then we can write that as minus 3 plus or minus the square root of 11 times I over 2. So, actually I said x here. It should be z. You know, same thing. It's just a z instead of an x, but same principle. So that means z is equal to minus 3 plus root 11 I over 2, or z is equal to minus 3 minus root 11 I over 2. Can you simplify root 11? No, just root 11. So those are your answers. They're complex roots. They don't actually intersect the x-axis. So the last question here, we have z is equal to minus 1 plus root 3 over 2i. Plot z and z times I on an Argand diagram. An Argand diagram is literally just like a typical XY thing, but it's just we have the imaginary axis there and the real axis here. So z is minus a half plus root 3 over 2i. So imagine this is going to be a rough graph. So we feel like we have minus a half x down here, and then we're going up root 3 over 2. So maybe like root 3 over 2 is there. So our point's going to be here. That's going to be z. If we draw a line like this, that's going to be the radius, or like r, the distance from this thing, the center. And then plot z times I. Well, z times I is just going to be minus a half I, and then we're going to have minus root 3 over 2, because we're going to have I squared, which is just minus 1. So then for z times I, we're going to be going minus a half down the imaginary axis, and then minus 3 over 2. Yeah, over here. It's going to look so... that confused me for a second. I should have rewrote this. This is actually just minus root 3 over 2 minus 1 over 2i, like that. So we're going minus root 3 over 2 on the x-axis, and then we're going, so that's going to be somewhere around here, and then we're going minus a half I down the imaginary axis. So it's going to look something like this. Minus 1 over 2 here, and then like root 3 over 2 here. Roughly. So it's going to look something like this. The key here, is that this is a 90-degree angle here. In between them, it's a right angle. So the key there is that, like, sometimes in an exam they could ask you, what is the multiplication by I? It's like a rotation of 90 degrees. See this guy here? This point has gone from here down to here. So multiplying z by I is like we've rotated the point by 90 degrees to the left. Now, write z in polar form. So, what is theta? Well, first of all, we're going to have to... Oh, hold on. The next part of this question, we want to rewrite z in polar form. So, to rewrite it in polar form, remember, we want r times cos theta plus I sine of theta, like that. So, we're going to need r, and we're going to need theta. R is simple enough, just Pythagoras. So, z, remember, is... I'm going to ruin my diagram here. Z is this guy here. So, we're going across minus a half, and then we're going up root 3 over 2. So, using Pythagoras, we're going to have r is the square root of 1 over 2 squared plus root 3 over 2, all squared. So, fill that into your calculator. Square root of 1 over 4 plus 3 over 4. Oh, it's just 1. Okay, so the radius is just 1. And then theta is going to be the inverse tan of the opposite over the adjacent. So, it's going to be root 3 over 2 divided by 1 over 2, like that. That's going to be pi over 3 is the angle then. Well, okay, no. This is where we're going to have to look at the diagram. So when you fill that into the formula, the opposite over the adjacent, we get pi over 3. That's the angle here. That'll be this angle here. I'll call that angle x. But we don't want x. We want theta. And theta is always the angle it makes with the real axis. So it's going to be this guy here. That's theta. So remember, a whole 180 degrees is just pi radians. So what we're going to do to get our theta, well, okay, I should have said this isn't actually theta. This is x. That means that theta must be pi minus pi over 3. Because it's like a full 180 degrees minus this angle we just got here to get theta. If that makes sense. That's equal to 2 pi over 3. That means in polar form, we can say z is equal to 1 times cosine of 2 pi, not just pi, cosine of 2 pi over 3 plus I sine of 2 pi over 3. Like that. Done. Now the last part is saying calculate z squared. To do that, we're going to use de Moivre's theorem. So de Moivre's theorem is cosine of theta plus I sine of theta to the power of n is equal to cosine of n theta plus I sine of n theta. Like that. So we already have z is cos 2 pi over 3 plus I sine 2 pi over 3. So that means that z squared is going to be cosine of 2 pi over 3 plus I sine of 2 pi over 3 all squared. That's equal to the cosine of 4 pi over 3 plus I sine of 4 pi over 3. And if you just throw that into your calculator, you should get minus root 3 over 2i, like that. That's that question done.